when we are wanting to find the inverse of two functions, or the inverse of a function, let me say that, we start with a one-to-one function. So it has to be a one-to-one function first, or it has to have the restriction of a one-to-one function to begin with. And then what we're going to do is the first step is we are going to replace the f of x or the g of x, the function notation, with y. Because that's what the function notation represents. It represents y. So we replace it so that we have an x and a y in the actual function. So let's start off, as I'm doing this, if we have f of x is equal to a negative 4x plus 1. And so that first step is to replace that f of x with a y. So I've replaced that f of x with a y, and then for right now I'm going to leave everything else as it was. The second step that we're going to do is we're going to interchange the x and the y. So interchange x and y. So replace all x with y, and we replace all y with x. So here I need to put an x where the y is equal to a negative 4 where the x is. I'm going to put the y plus 1. So you've noticed I've switched where the x and the y are. Step number 3 is I'm going to solve for y. So I need to solve this for y just like I normally would. So I'm going to subtract the 1 first, and I get x minus 1 is equal to a negative 4y. My next step would be to divide everything by a negative 4. So I'm going to divide each of these terms by a negative 4. And so I would get a negative x over 4, or negative 1/4 x, plus a 1/4 is equal to a y. Now, here you could have a negative x plus 1 over 4. You just need to make sure that you go ahead and get that negative out of the denominator. And so you just need to divide each of those signs, and that would be fine as well. Either one of those would work. Okay? Your last step is going to sound crazy, but you want to go back and replace your y by f inverse of x. Or if you started with g, use g inverse, h inverse, whatever your function name was. This way you are showing that this is the inverse of what you started with. So in our case, we started with f of x is equal to a negative 4x plus 1. Our inverse now, f inverse of x, is equal to that negative x plus 1 over 4, or that negative x over 4 plus a 1/4. Either one of these. So you're showing that these two are inverses of each other. That's what the replacing the y by f inverse is representing. Let's solve another one of these. Let's start with if I have h of x is equal to a 2x to the third plus 3. So again, my first step is to replace my my h of x with a y. And I have 2x to the third plus a 3. Wherever there's an wherever there's a y, I'm going to replace it with an x. And wherever there's an x, I'm going to replace it with that y. And then I solve. So I'm going to subtract my 3. So I get x minus 3 is equal to 2 times y raised to the third. And I want to be consistent. I divide both sides by 2. So I get x minus 3 divided by 2, not another 3. Let's see. Is equal to a y raised to the third power. Now, I need to get rid of this third power. In order to get rid of the third power, we are going to take the cube root of both sides. Now make sure that the entire fraction is underneath that cube root. Since it is an odd power, I do not need to do the plus or minus. I just need to take the cube root. So I'm going to have the cube root of x minus 3 divided by 2 is equal to my y. And then I replace my y with h inverse of x, and that is going to be equal to the cube root of x minus 3 divided by 2. All of this is underneath the cube root. I want to do one more, and this one is going to have x's in 2 locations. So this one is going to start out with g of x is equal to a 3x divided by an x plus 1. So you'll notice that I have x in 2 different locations. So I'm going to have y is equal to a 3x divided by an x plus 1. That was my first step. My second step is to replace every y with an x, and then every x with a y. So I replace this with a y, and I'm going to replace down here with a y. So I've replaced both of these x's with y's. Now I need to solve for my y. Well, this one's a little bit different because I don't have just a single y to solve for. First thing I need to do is I need to get rid of this denominator. So I need to multiply both sides by this denominator. So I'm going to multiply both sides by that y plus 1. And that way it will get rid of that denominator. And I will have y plus 1 times an x is equal to a 3y. I'm going to distribute the x. That way I get a yx plus an x is equal to a 3y. I have y's on both sides. No, I cannot just divide by a y. I cannot do any of that. What I need to do is I need to get all of my y's on one side. So I need to move all of my y's to this one side. So I'm going to subtract this yx. So I'm going to have x is equal to a 3y minus the yx. Now it can be xy, it doesn't matter, because remember, multiplication can be in either order. The reason I'm doing this is I'm trying to get all the y's on one side. Now again, I don't want to divide both sides by a y because then I get x in the denominator and everything else. So what I want to do here is you'll notice that both terms have a y. I want to factor out a greatest common factor of a y. That way I get y times a 3 minus x. I have taken a y out of both terms, and I'm left with a 3 minus x is equal to x. Now I can divide both sides by this 3 minus x. Please do not cancel out these x's. They cannot cancel out. The 3 minus x must go as a group. Now we started with g of x, so this is g inverse of x is equal to an x divided by 3 minus x. We started out with g of x is equal to a 3x divided by an x plus 1. These two are inverses of each other. So you have to be careful whenever you get two y's and you're solving for the inverse.